My name's Ashley King. I'm a UKRI Future Leaders Fellow based at the Natural History Museum in London. We've just received a sample of asteroid Ryugu from the Japanese Space Agency that we'll be studying to learn about the origins of our solar system. So the sample we have that survived here at the museum is about 1 millimetre or so in size, tiny little black speck really. So this sample, or the mission, actually collected about 5 grams of material. So this sounds like a really small amount, but we can actually study that almost atom by atom and learn about how our solar system was formed and how we ended up having a planet like the Earth. So the asteroid Ryugu is what we call a near-Earth asteroid. So we think it probably formed way out at the edge of our solar system, but over the evolution of our solar system, it's actually kind of transported itself. It's been kicked in maybe by the gravity from planets like Jupiter into an orbit that's much closer to Earth. So what the mission did is it went and took some images, and then it actually landed on the surface, collected some samples and brought them back so that we could study them here in the labs on Earth. So one of the biggest questions we have in planetary science is why do we have life and why do we have water here on the Earth? We think the Earth probably formed too close to the sun for there to have been water and kind of organic materials in the initial ingredients. So one of the ways you can do that is by delivering those things from the outer solar system where temperatures are much colder. And so what we think with Ryugu is that it would have formed way out at the edge of our solar system. And so the original materials, the water as ice, organic type materials, carbon and hydrogen and nitrogen bound together would have been there in that asteroid. And so what we're trying to do now by studying the samples is understand what's the composition of those, how does that compare to what we find on the Earth, and are these carbonaceous asteroids like Ryugu really the starting point for habitable planets? The Hayabusa 2 mission is only the 5th ever mission to collect samples from a known object in the solar system. And it's the first mission to bring back samples from a carbonaceous asteroid. And so I've been waiting 7 years since this launch to actually get my hands onto this sample and start studying it here at the museum.